All right, so today's all requests, and the first one is for override. So override is not required. Let's put it that way. The override annotation exists to help you avoid making mistakes. So I'll just grab a random playground here and we'll kind of do this, right? So let's say I have a person class and I override the toString method. And I return person. And then now that I've done that, I can do person is equal to new person. And if I print that person, my override method will be used. And I can print I'm a person. Just so we know that it actually is being used. So the override annotation is not required. The reason it exists is to help you make sure that you're actually overriding something. So, you may be extending another class. That class may have some method. You may be trying to override that method, and you may mess up. Now, the ones that we're overriding so far are like pretty common methods that are part of capital O object, and so those, there's only a few of them, and they're fairly easy to remember what the method signatures look like. But what happens here is if I add this annotation, obviously nothing happens here, but let's say that I fat finger this, let me type it in something that looks right. Oh, it doesn't like that because it's not something like that, right? And that's kind of obvious. Maybe something like this, right? Now again, I'm just introducing this typo to show you what happens. And so what the override annotation does is it tells Java, this method should override something from a superclass. If it doesn't, the compiler will bark at you, right? And this is one of those, this is one of those things about, Java where we're essentially using the compiler to help us. We're human beings, we make mistakes. The compiler is a piece of computer code. It might have mistakes in it, probably not at this point. I mean, the Java compiler's been around for a while, so maybe there's still some bugs left in it. And obviously, if they make changes, they can introduce new problems. But the idea is that let's let the computer do what the computer is good at. And one thing the computer's really good at is comparing two things to each other, right? So it's like, okay, this method here, you said it's supposed to be overriding something, so I can, the computer can very, very quickly and efficiently check in my superclass, in my parent's parent, in my parent's parent's parent, go all the way up the tree to figure out kind of what is actually going on here, right? And to see if this actually overrides something. So that's something the computer is very good at. If you give it this override annotation, you're basically telling the Java compiler, please, on my behalf, check to make sure that this method signature overrides something from a superclass. If it doesn't, I get this error. So this is really why this exists. It's an example of a place where you're putting the compiler and the computer to use doing something that computers are good at, which is in this case, checking something for you, right? For standard object methods like override, for standard object methods like toString, it's hard to get these, well, I don't know. I shouldn't say it's hard to get these wrong. I mean, I mistyped it when I was starting to type the examples, so I'm not sure that it's fair to say it's impossible to get these wrong. It's unlikely. You'll get used to them, but this particularly comes into play when you're working with other classes, right? And this could also happen. So let's say that you're extending a class. Let's say you're designing a system and you're working with somebody else and you extend a class that they wrote. And then maybe they come back later and they decide, oh, that method, I don't like the name. I'm going to rename it. Well, now your override doesn't match anymore, right? Because their method was called foo. I mean, we can do an example of this, right? So let's see here. Let's create a method in here. We'll call it public void foo. And then we'll just have it be blank. And then I'll create a student class that extends person. And I'll call this student. Yep. For now, I'm just going to leave this blank. So I say student is equal to new student. and I should be able to call foo, right? Because every student is a person, foo, and every student has a foo method. So now let's say you override foo. I say, okay, I want my own implementation of foo. So I add foo, and I say system.out.println foo. I'm very fooey. Now that's going to do this, okay? But now let's say that the person class overrides foo, and let's change this to be a person object. So I know I can call foo, but let's say they change it to food. Now my override doesn't match, right? So the override that I wrote before, so it's safer, right? Okay, it's safer to name this, to use an override here, right? That'll still work, I still get the overridden behavior, but now what happens is if my parent class goes ahead and messes with me, then I have this error, which will help me remind me that if I want to override foo, it's not called foo anymore. And so this is, one of the examples of this. Are there other types of annotations? Oh yeah, and there are annotations all over the place when you look at sort of production Java code. It's not this is actually the first semester that we've ever discussed annotations at all. It's not a rabbit hole I want to go too far down, but yes, the annotations are a feature of the Java language, and they are again when you look at sort of real Java code, you will see them. And when we start using Android, we'll probably have to use some in various places, and we'll kind of have to hand wave a little bit and to kind of hope that you don't. Well, we'll try to explain it as much as we can, right? Because this is a feature of the Java language that's used in real production systems, and just not something that we get into too much. It's not super appropriate for beginners, I would say. The override annotation, I would say, it's probably one of maybe one or two that I would say is worth talking about, in the sense that it is useful. It's also built into Java. That's a great question, actually. Let's look at Java built-in annotations. I'm just curious about how many of these are, okay, yeah. Okay, so it looks like here are, interesting. So override indication, suppress warnings, deprecated. Okay, so there's, I don't even know what some of these things are. Target. Yeah, okay, these are annotations for annotations. Anyway, so you can see that there's a pretty small group of built-in Java annotations. Another one that is sometimes useful is this sort of suppressed warning. So let me show you what that does. And to do that, I'm going to have to, let me pull up IntelliJ here. Let me pull up IntelliJ. All right, so, and I'll adjust my display in a minute to get this on screen so we can see this together. Let's see, okay, face an idea. Oh, there I am, check it out, okay. So I'm going back and we're looking at our tic-tac-toe code again that we wrote a week ago, I guess, yeah. Somebody asked, can we do this in IntelliJ? And so we went through the tic-tac-toe example in IntelliJ. And we're all, we're already, so IntelliJ, one of the things it'll do for us is it'll give us these helpful hints about things. And one of the things that both IntelliJ and the Java compiler will cause us to, will sort of warn us about is if we have an unused method. Let's add an unused method here. I'm just going to add a void method. All right. Okay, so that's fine, and you'll see here immediately it's claiming that it's never used, and what it's doing is it's checking all the code it knows about. It's trying to figure out does anything ever call whatever, and so there are times in which the right thing to do is get rid of this method because it is unused. There's other times when this method is actually used by some piece of code that this doesn't know about or whatever, and so what we can do to shut up this warning is we can add this this annotation that suppresses this warning. So this is another example of an annotation. You can see here. Let me blow this up a little bit. Appearance, presentation mode. Yeah, this will boost the font a little bit, I think. There we go. So you can see here, this annotation has a little bit of a different format. It actually takes a string as sort of an argument. And the string describes what type of warning I should ignore. And I'm attaching this annotation to the place where the warning is, right? If I put this annotation somewhere else in my code, it wouldn't work. So this is just another use of annotations in Java. Probably one of the more, and I feel like at some point it will, let's see here, exit full screen, and then also, oh, that's actually kind of nice. Well, no, I don't know how to use IntelliJ well enough to be able to do it this way. So, so that's another place where you see an annotation being used. There are also, let me go back to my other view. There are some, so one of the, annotations are actually super powerful. There's a lot you can do with them. And the reason for this is that annotations can be processed both when the code runs, but also when it's compiled. So if you see here, that's when this override annotation is being used. So this code doesn't even compile. It's not that this is checked at runtime. This is checked when the code compiles to make sure that foo actually overrides a method in one of the superclasses. And so because annotations have access to sort of the code as it's being compiled, there's actually quite a bit you can do with them. One of the things that I've seen libraries start to do with annotations, and I'll just show you this because you may see this in some code that you find online, is let's say this takes an object and I'm going to print that I don't know why. And I'm just kind of using this as a weird example. And now I'll just have it print itself. Let's see here. Why? Oh, because I've changed that as a person. So I need to change this so that it matches. Okay. So now I'm just printing the student. We talked a little bit before about null in Java and how dangerous this can be. And so there are some libraries now that provide an annotation that looks something like this. And what this annotation does, you'll see if I try to compile the code, it's not going to work right now because I can't find this annotation. This is not an annotation that's built into Java. But what this annotation does is, these assertions that we've been putting in sometimes where we'll say assert O is not equal to null. You can think of that annotation as basically doing the same thing. It automatically adds a check to ensure that that variable is not null. And it will sort of die if it's not null. So you can add this. An annotation can be used on in this part of the code as well to annotate a parameter. So anyway, at some point maybe they'll actually add that to mainstream Java and then we'll be able to use it in our code. But for now it's sort of buried in libraries and it's not something that is part of the built-in language. Does Java have special methods that allow classes to interact with other classes more easily? Can you elaborate on that? Well, you mentioned something called dunder, which I don't know anything about. So let me look up this. Python dunder. These are magic methods? I didn't know what these were called. I've used these before. If this is what you're talking about, so let me try to kind of, I can talk about, I don't know, that's a great question. I think it probably depends on the null, not null annotation. Let's see here. Yeah, so these look like they're part of libraries. Looks like JetBrains has one of them. Let's see here. And it looks like they're also using this to check for potential null cases. Yeah, I'll have to look into these more. I think it depends on the library that you're using. So going back to talking about these special Python methods, from my familiarity with Python, which is somewhat dated at this point, if I remember correctly, those methods allow you to do things like, so you can kind of make your Python class behave like an array or like a dictionary using those methods. Java doesn't really have an equivalent of those methods, particularly when it comes to overloading. So what do we mean by overloading? So there are, when you guys go on and take CS225, or if you take CS128 next semester and you do some work in C++, C++ is a language that allows you to do a lot of what's called operator overloading. What does that mean? So what that means is that when I overload an operator, that allows me to do something like this. So let's say I have two students, and what I can do is I can add, at that point, I could add them together. I could do something like this. What I need to do in order to, so if I try to do this in Java, it's going to tell me these are bad operands, right? Because there's no operation that's been defined for plus that takes a student and a student as operands. In Java, there's no way to define that operation, right? So there's no way to make this into a meaningful statement. In C++ and certain other languages, you can. You have to do some work on the student class. So you essentially have to tell, you would have to tell the language what to do. Like when you find two students separated by a plus sign, what should happen? The only place in Java is really interesting. So the only place in Java where this happens is with strings, right? So if these are strings, so in general, the Java mathematical operators are always mathematical. They can only take numeric arguments. The only exception is with strings, obviously. So we've seen this before where we use strings to do concatenation, and that works fine. So if you think about it, plus is the only operator in Java that's overloaded, and it's only overloaded for strings. So I can use plus to add two numbers together, in which case it has one meaning, which is addition. I can use plus between two strings, in which case it has another meaning, which is concatenation. So it's the same operator, and now the operator itself is overloaded. There are, again, languages, I don't know if Python allows you to do this or not, but there are languages that allow you to essentially do this. So I can take mathematical operators, I can take other types of operators in the language, and I can modify their meaning to, to do different things. Is this a good idea? I think the results are mixed. I think this is certainly a powerful feature. It can be a good idea. It really depends on how you use it. So for example, one of the things I remember from Python, for example, is that in Python, I can override some of those dunder methods you talked about that start with two underscores to make my class look like it's an array. But then I can do all sorts of weird things that arrays wouldn't normally do. And so it's kind of like, okay, if you really need to support square bracket syntax for your type of Python object, you can do that, but people have an expectation about what that means, right? In the sense that, for example, if I put something into position 0, I expect to be able to get it out later and have it be the same thing. In Python, I can make a class that doesn't do that, right? It just gives me a random number later or whatever. And so I think that can get a little bit messy. I don't know. This is a great question. I guess this is not the languages that I tend to enjoy and use don't really have this as a very forward feature, right? There are some languages like C++, for example, where this gets used all the time. For me, it's sort of like, why? You're just adding more. So now every time I see a plus, I've got to think about what's happening here, and I need to know what the arguments are, and usually it's just add a method. Just add an instance method to one of them and call it, and that way I know what's happening, right? It's I think with strings is about the only time in which this sort of makes some degree of sense. But it's not clear to me that introducing a lot of ambiguity into familiar symbols in a language is really a good idea. It's again, how desperate are you to make things look like math? Now, again, certain cases where this makes sense. So let's talk about, we can think about plus, for example. Right? I know this is a digression, but that's what we do in these walkthroughs, so that's fine. Think about the cases in which plus might have a natural meaning. So combining two numbers, obviously, addition. Combining two strings, I think that's reasonable. That's concatenation. Two lists, same thing, concatenation. Or I could potentially combine two arrays by creating a bigger array that contain all the elements from the first array followed by all the elements of the second array. That seems to be reasonable. Same thing with a set. We'll talk a little bit more about data structures later in the class. Taking one set of items, which is like an array, but it doesn't have order. It's like a bag of stuff. And then dumping another bag into it. So that's set addition, just combining items from two sets. Past that point, I don't know. I mean, I think things start to get a little bit dodgy, iffy past that point. So, if you're defining a plus operator for operands other than some of those, I think it starts to become a little bit strange. And it might be better to just, again, it's like, why are we so desperate to reuse symbols that, it's like, oh, cool, I can make plus, make something. It's just one of these things that's like, cool, I guess, and probably useful in some very, very unique circumstances, but not something I would encourage people to use liberally, because I just think it makes for very, very, very difficult to read code. So again, imagine that, like, you think you understand what plus means, and now you start reading code where somebody is using it in this sort of unintuitive way to combine two instances of their class that doesn't, like, you keep thinking it's addition, and then you get confused and stuff like that. So again, I would say, think long and hard before you utilize some of these features. Multiple extensions. So that's something I should have covered. I'll come back to this next week. No. So can Java? Can you extend more than one class in Java? No. And the reason for this is something that's sometimes known as the something called the I think it's called the diamond, right? The diamond problem. And we can find a picture of it, right? So here's an example. Let me pull this up, make it nice and big. So here's an example where D inherits from two classes B and C, and then they both inherit from some class A. So the problem is, let's say that A provides some method, meaning that all of its ancestors inherit it. But let's say that B and C override it differently. What should D inherit? Right? So if B provides one override, let's say D doesn't override it, right? So, A provides it, so all A's children have it. B and C, or maybe B overrides it and C doesn't, right? Or maybe C overrides it and B doesn't. And so this introduces this ambiguity. And rather than, there are some languages that have ways of addressing this, but rather than addressing it, Python doesn't allow this for classes. Now, not next week, but the week after, we're going to talk about interfaces in Java. And interfaces actually do allow you to implement multiple interfaces. And so in many ways, they're a much more flexible abstraction than classes. In the code that I've written in Java and the code I've seen other people write, I've actually seen interfaces as a much more powerful concept in Java than class hierarchy, which is one of the reasons that we're not really pushing the class inheritance stuff too hard. It's a part of Java, it does get used, but there's an inflexibility to it, right? So one way to think about it is, if I've got a class in Java, it can only be at one, and it's part of this big tree of classes, right? Where object is the root and everything inherits from object, but it can only be in one spot. And there's times when I want like a mixture of different behaviors drawn from different places, and I can't do that very effectively with inheritance, particularly not with just single inheritance. And so Java's interface mechanism provides an alternative, which is much more flexible. So no multiple inheritance in Java. Does Python have? Let's check this out. Inheritance. Let's see what Python does about this. Okay. And I guess there must be some. So whenever you have the diamond problem, you have to have a way to address this ambiguity, right? So essentially, you need some way of D indicating, should I inherit from B or C? Now if B and C may add different methods, right? And I'll inherit all of those. But the question is, particularly again, if A provides a method and B or C override the method, which override do I take? Do I take B's or C's? And so I need some way of addressing that ambiguity before I can get multiple inheritance to work. Good question. By the end of the semester, what can we expect to do with Java? So starting in a couple of weeks, we're going to build a simple Android app together. I'm not going to claim that this is going to be some big complex thing, because it's not. Because, there are many people in this class who are beginners and hadn't seen Java at all until 4 weeks ago. So, I'm not going to slam. We've done this in the past, and part of me kind of decided at some point, like, this is not a good idea, and it's not encouraging the right kind of thought patterns. So we're going to show you some Android. Even that, done as simply as possible, is still going to be a big leap, because Android is a big, complex system that requires wrapping your mind around a lot of things. It requires operating under a lot more uncertainty than you're used to. But yeah, I mean, but I think that if you look at what other students have been able to do by the time they finish this class, I mean, they've been able to kind of like, pick up Android and build some pretty simple apps, right? Particularly kind of following a tutorial, making some modern modifications and stuff like that. But that's kind of where I expect you guys to get. That said, I mean, building things is not the only objective of this class. And so once, we have essentially 2 more weeks of work on object-oriented programming. And then we get to the stuff that I really think is a lot more fun, because at that point you guys will have seen enough syntax to be, pass final project, sure. I have a whole website up with these. I'll send you a link. It's up. These are up on the old site. Let's see. Info, fair. What about spring 2019? Was that last semester? Fall 2020? I don't know where let's see here. Okay. So here's, this is the last in-person fair that we did. There it is. Yeah, so you can check those out. That has of all the projects and stuff like that. We used to, back when we met in person, we had a big final project fair at the end of the semester. I don't know exactly how we're going to do that this semester. Last semester, things got weird really quickly, and so we did kind of a fairly low energy online version of it. I'm not sure exactly how we'll do it in the past. This is the kind of thing that's hard to do in a satisfiable way, online, right? It's just a lot more fun to pack the building and bring in pizza and stuff like that. So, there's usually a bunch of like challenge themed projects, which, I don't know what to say about other than some of them are funny. That's where we expect to get you. But what I was going to say is that, the next, once we get through the syntax and just some of the conceptual ideas, then we kind of get to this point where it's like, okay, well, let's build some cool data structures and talk about some cool algorithms, and that's actually really fun. And we're going to get you guys to the point where, so sometimes I think of, the process of, starting you off in computer science as building layers. My class builds a certain layer, of knowledge. And then if you go on and you take the next class, that builds another layer. And then the next class builds another layer. And at some point we start to spread out too, and we actually give you different chunks of stuff. But for the first 3-4 semesters, I mean, we really are kind of repeating a lot of things because we're doing them again and again and again. And every time we do it, it's like we do it a little deeper, So you guys see some data structures and algorithms in my class. We talk about big O analysis at a very high level. Then you go on, you take CS 173, you see some of the math behind it. You do a little more of that, a little bit of a deeper level. Might take 128 if you're taking that class, or in the future, people that will take, the follow-on course, do a lot of the same topics, but deeper, right? You get to 225, deeper, a lot of the same topics. 225 has people implementing lists. I was looking at their MP the other day. I was like, this is basically the, a version, they do more features, but there's a lot of overlap between the homework problems that we ask you guys to do on lists and what you do in 225. They're doing it in C++, more challenging language. They're adding some additional features, stuff like that. So I'm certainly not saying they're doing the same thing, but it's deeper, right? It's an extension. It's repetition, but every time, we do a little bit more. And so we'll get, we give you guys kind of the first covering. And so we do see some, some of my colleagues like to call them baby data structures, but whatever, they're data structures, right? So, lists and trees, and I don't think we'll do graphs this semester, but some of the beginnings of some of those, you guys will write some algorithms and we'll reason a little bit about their complexity at a very high level, right? This is not a course where we go deep into the math or the proofs or any of the actual rigorous analysis of stuff. We'll do the hand-wavy analysis, but a lot of times that's enough to kind of develop intuition that's useful. So, good questions. All right. Other questions before we break up. Out of questions for the week. Oh no, well, what are we gonna do? All right, well, hope you guys, I can sign off unless there's other people who want to ask questions. I'll stick around for a few minutes. If you guys have sort of non-content related stuff, just a reminder, I'm doing office hours this afternoon from 2 to 4. You guys are encouraged, welcome to come by. And I'd love to talk about whatever, right? So that's not designed to be, a conversation about the course content. It's supposed to be a conversation about kind of whatever's on your mind. And I think there's some sort of like form that people taking this class have to fill out where they have to ask certain questions, but they're usually pretty good questions, and so they're fun to deal with. So, all right, anything? Yeah, absolutely. So and let me just emphasize this, right? This walkthrough is not a replacement for the lesson, right? If you have to choose between coming to this and actually going through the lesson, go through the lesson, right? I mean, that is the authoritative content. I am not going to promise that I'm going to go through that material, particularly to the degree that you would need to see it for the quiz. This is in addition to, certainly supplemental. We can talk about some other things. I can answer some questions. Sometimes I'll give a brief high-level overview. But it's definitely not designed to replace the lesson walkthrough. I mean, that is the number one, your number one priority every day is to go through the lesson, including all the walkthroughs, and do the homework problem. Past that, what else you want to do, whether it's come hang out with me at 11 or go to some of our other sessions or jump on the office hours thing or come on the forum, those are designed to help you get help when you get stuck or when you don't understand something. But the primary content of the class is the lesson, and particularly all the walkthroughs and stuff like that. Those are kind of, that's what I expect you to be responsible for when I sit down and I write a quiz. So yeah, absolutely. I won't get too lonely. All right, so I'll stick around for a few more minutes. Yeah, so there's a Coding Bat, which is a nice site. You guys haven't seen that one before. It's actually pretty similar. So, it's got a lot of, little simple Java problems. Let's see. First and last element, right? So, things like this, right? So I could say return new int nums 0 nums length 1. I'm assuming this will work. There you go. So yeah, they've got a pretty cool page here, and yeah, maybe it's not as pretty as what we do on our site, but it's super useful. And so it's a pretty nice tool. Definitely recommend that. And they have, a variety of different problems here, right? Let's see. As much as will fit. Let's see here. I'm sort of confused about how to do this one. Oh, I see. Okay. Yeah, so you basically go through all the first ones and all the second ones. So these are nice. They're also kind of like fairly straightforward. Past that, there's like kind of leak code type websites out there that are useful. I hope some of you guys come back next semester and help us continue to write problems, because we have a nice tool for doing that now. And so I'd love to get to the point where we have 1,000 small problems that students in the class can work on and for more practice. So, all right, I think that's going to be it for me today. Hope you guys have a great weekend. I will see you on Monday.